everyone, for what values of x does the series converge absolutely or conditionally and conditionally? And also we're going to find the interval of convergence. We're going to use the ratio test. I'm going to write this out here. We have the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. Now, if it's less than 1, it's going to be absolutely convergent. Greater than 1, it's going to, if our limit is greater than 1, it's going to be divergent. If it equals 1, then it's inconclusive and would have to use a different test. So let's go ahead and fill this in. We're going to have the limit as n approaches infinity of absolute value of x plus pi to the power of n plus 1 divided by square root of n plus 1. And then we're dividing by a sub n, which is the same as multiplying by the reciprocal. So this is going to be square root of n divided by absolute value of x plus pi to the power of n. Let's put this straight line. So let's look at this piece right here. This is like saying absolute value of x plus n, or pi, times absolute value of x plus pi to the power of n divided by absolute value of x plus pi to the power of n. So that cancels out, and we're left with absolute value of x plus pi. Okay, then we have our n parts. That's the limit as n approaches infinity. They're both square roots, so we can just write the square root of n divided by n plus 1. Okay, so the limit of this is just 1. So our limit's going to equal absolute value of x plus pi. And for it to be absolutely convergent, it has to be less than 1. So therefore, we would have, for that, by definition, this is going to be x plus pi is less than 1, but greater than negative 1. So you subtract pi from both sides, we're going to have negative 1 minus pi is less than x is less than negative pi plus 1. And let's just write this as negative pi minus 1. So it looks more symmetric here. All right. So that's what we have. Our x is going to be convergent where x belongs to this interval. Negative pi minus 1, comma, negative pi plus 1. Because we're going to have to test this. All right. Now, it's going to be divergent if absolute value of x plus pi is greater than 1. So just write that it's divergent. I'll put diverges. So now let's check our endpoints. So we're going to check for x equals negative pi plus 1. And that's going to be the sum from n equals 1 to infinity of 1 divided by square root of n. So this is really 1 divided by n to the 1/2 power, and 1/2 is less than 1. It's a divergent p series. So at this endpoint, this is divergent. All right. Now let's check for x equals negative pi minus 1. So that's going to be, I should have put colons here, the sum from n equals 1 to infinity from negative 1 to the power of n divided by square root of n. Now, this does not converge absolutely, but we can use the alternating series test and look at that. So for the alternating series, we have the sum from n equals 1 to infinity of negative 1 to the power of n divided by square root of n. Well, this is positive, given here, so that checks. We want to see if I check square root of n plus 1 is greater than square root of n. Therefore, 1 divided by square root of n plus 1 is less than 1 divided by square root of n. Also, the limit as n approaches infinity of negative 1 to the nth power divided by square root of n, this is going to equal 0. So it is convergent by the alternating series test. Therefore, our final results are the interval of convergence is, since this endpoint is convergent by the alternating series test, we use closed interval negative pi minus 1. It was divergent for our other endpoint at negative pi plus 1, so that's open interval. It converges absolutely on the open intervals negative pi minus 1, comma negative pi plus 1. And it converges conditionally at x equals negative pi minus 1. All right. Thank you. Have a nice day. Bye-bye.